Welcome back to the deep dive. This is where we really get into the weeds with expert source material and try to turn it into knowledge you can actually use day to day.
Exactly.
If you're dealing with infrastructure, whether that's on-prem servers, cloud architecture, or fighting the latest identity fire, your time is definitely valuable. So today, we're aiming to give you a bit of a shortcut.
Yeah, think of it as a shortcut to understanding how seasoned pros handle advanced infrastructure crises.
Our source material today is basically like sitting in on a massive, super high-pressure technical interview, the kind that covers the nastiest failures you can imagine across AD, Windows Server, virtualization, even Azure and AWS.
Right, the stuff that keeps you up at night.
So our mission really is to pull out the strategic playbooks from all that. We want to show you, the listener, not just what commands to run, but how experts think, step by step, when things go sideways and the pressure's really on.
It's all about having a structured approach. Because, let's face it, when critical systems fail, panic doesn't help anyone. What we're offering here is a process. Diagnose, isolate, recover, and this is key, prevent it from happening again.
Think of this deep dive as your blueprint for that next critical incident, because, well, there's always a next one, isn't there?
There usually is, yeah. Preparation is everything.
Okay, let's dive right in. We'll start with what's arguably the heart of most enterprises, and maybe the most fragile part, identity services. This is part one, the core identity crisis, focusing on Active Directory and group policy failures.
Absolutely. If Active Directory starts to wobble, everything feels it. Users, servers, applications, they all depend on it. So it makes sense to start right at the core of domain authentication. Kerberos, hashtag, hey, Kerberos authentication failures. The time bomb.
All right, scenario one, and it's a nasty one. Kerberos authentication is failing, but only sometimes, maybe across different sites. Users getting frustrating access-denied errors, but it's intermittent. When that identity foundation feels shaky, where do you even begin?
You start with the clock, always. Kerberos is, well, it's incredibly sensitive to time synchronization. The client and the domain controller, the DC, they need to agree on the time for the authentication tickets to be seen as valid.
How sensitive are we talking?
We're talking usually a default skew of maybe 5 minutes, sometimes less, depending on policy. If the time difference is bigger than that, the ticket timestamps look wrong, expired, or not yet valid, and boom, authentication fails. That's why people sometimes call Kerberos the time bomb.
So if the server and the workstation disagree on what time it is, the whole process just breaks down. What's the first command you run?
Right. The immediate check is W32T meter query status. You run that on the domain controllers and also on the affected client machines. But it's not just about individual machines. You have to validate the whole NTP hierarchy, the network time protocol structure.
So hierarchy, you mean how the DCs get their time?
Exactly. All DCs need to sync time correctly, but critically, the PDC emulator role holder in the root domain. That one specific DC acts as the authoritative source for the whole domain. That PDC absolutely must sync its time with a reliable external source, like a secure public NTP server.
And if it doesn't? If it syncs with another internal DC?
Then the whole domain can slowly drift away from actual time, and you start seeing these weird intermittent failures because different parts of the network are slightly out of sync.
Okay, so checking the time locally is step one.
Yeah.
But you said intermittent failures often point to deeper issues, right? Like replication or network problems.
Precisely. Once you've either confirmed time is good or you fixed the NTP setup, then you dig deeper. You start correlating events. Look at the Windows event logs for specific IDs.
Which ones are key?
You're looking for 4, 11, and 13. Those are classic Kerberos-related event IDs. They might signal a bad ticket or a sync issue directly. And you look at those alongside event ID 2089, which screams replication problems.
Replication. If the DCs don't have a consistent view of the AD database,
then authentication is basically guesswork. A client might hit a DC that doesn't have the latest password update from the PDC yet, leading to those sometimes it works, sometimes it doesn't, failures.
So you check replication health.
Yeah.
What else?
You need to validate the basics too. DNS SRV records. Are they correctly pointing clients to their local DCs? Run repadmin repunnery. That gives you a quick domain-wide view of replication health. If you see errors or high latency there, that's a huge clue.
Okay.
But here's one that often gets missed. AD sites and subnets mappings. If those are wrong, a client in, say, London might be trying to authenticate against a DC in Sydney. That slow communication across the WAN can cause timeouts that just look like Kerberos failing intermittently.
Right, so it's not the protocol itself failing, but the network infrastructure underneath letting it down. Makes sense.
Mm-hmm.
So once you've found the issue, bad NTP, Broken replication, weird site links.
Hmm.
What's a fix and validation process?
It's often layered. First, fix the NTP config point that PDC emulator to trusted external sources. Second, correct any broken site links or subnet misconfigurations. If replication is really bad, you might need repadmin commands to force things or even clean up lingering objects, though that's more advanced.
And validating the fix. You can't just assume it's working.
Absolutely not. Validation is critical. You need to perform synthetic Kerberos logins. Try logging in as a test user, request a service ticket, something to actively confirm that tickets are being issued and accepted correctly across the board. Only then can you really say the incident is resolved. #TAC-TAC-BB, group policy changes, not applying the hidden conflict.
Okay, let's move on to group policy objects, GPOs. Oh, the frustration that can cause. The scenario here. You set up a GPO, it looks perfect in the console, but some servers just aren't getting the update. The settings aren't applying.
Yes, the classic, but it looks fine here problem. This is usually down to some hidden conflict, maybe filtering or replication lag. The management console can definitely mislead you.
So where do you start diagnosing when the console says one thing, but the server does another?
You have to go to the endpoint itself. The first step is always to run gpresult-h on the affected server. That generates a detailed HTML report showing exactly which policies applied, which were denied, and importantly, why. Or you can use the RSOP tool, resultant set of policy.
That tells you what happened, like policy X was denied. But finding the why, that's the tricky part.
That's usually where the real detective work starts. You need to check the gates that control GPO application. The most common culprit, honestly, is filtering. Either security filtering, maybe the server isn't in the right group, or a WMI filter.
WMI filters. They let you target based on OS version or registry keys, right? Powerful, but easy to get wrong.
Exactly. They're super powerful, but also super easy to mess up. A slightly wrong query can unintentionally exclude whole groups of servers. Beyond filtering, you absolutely have to check AD replication health again. But for GPOs, you need to look specifically at DFSR backlog.
DFSR, Distributed File System Replication. Why is that the key here, not just standard AD replication?
Good question. AD replication handles the database objects, user accounts, computer accounts, group memberships. But DFSR handles replicating the files stored in the SYSVL share on each DC. And SYSVL is where the actual GPO templates, the scripts, the settings files, that's where they live.
So if DFSR is lagging, the DC knows the policy should apply, but the client can't actually download the settings files.
Precisely. The client tries to fetch the policy files from SYSVL, but if they haven't replicated to that specific DC yet due to a backlog or maybe even a journal wrap condition on the DC, the policy just won't apply. The client basically gives up.
That AD replication versus DFSR replication distinction is really important for GPOs then?
It's fundamental. You also need to look for more complex GPO behaviors, slow link detection, for instance. If the client thinks it's on a slow connection, it might just skip applying certain GPOs to save time, even if the link isn't actually that slow.
And loopback processing, I hear that causes confusion.
Oh, definitely. GPO loopback processing is often used on things like terminal servers or kiosk machines. It forces user policies to apply based on the computer's OU and GPOs, not the users. This can lead to really unexpected results where computer settings override the user settings you intended. Very confusing if you're not aware of it.
So the fix involves checking all those filters, making sure the computer or user object is in the right OU, has the right permissions.
Exactly. Check the WMI filter logic. Verify security filtering, make sure the server object is in the correct OU and that authenticated users or the specific target group has read and apply group policy permissions. That's crucial.
And if it is a DFSR issue?
That can be trickier. You might need to force replication or use DFSR diagnostic tools, but that's potentially disruptive, so you plan it carefully. And finally, always reevaluate GPO precedence. Remember, policies linked lower down the OU structure or with higher link order take precedence. A policy applied high up might be getting overridden unintentionally. You have to understand that order of application. #TAC-TAC-TAC-C. Troubleshooting intermittent user lockouts.
All right, next up, intermittent user lockouts. These always seem to happen at the worst possible time, maybe to a VIP, and suddenly it's an all-hands-on-deck P1 incident. We need a fast, efficient process for this.
Speed here comes from having a clear tracing method. The absolute starting point is Microsoft's Lockout Status tool, or a similar AD lockout diagnostic utility. It tells you immediately which DC recorded the lockout event.
So that DC is the key.
That DC is your pivot point. Knowing which DC saw the bad password attempts lets you focus your investigation on the security logs on that specific DC.
Because the lockout event itself isn't the cause, it's just a symptom, right? You need to find what's actually sending the bad password over and over.
Exactly. You need to trace the source machine, and the best place to find that is usually in the netlogon logs on that authenticating DC.
Netlogon logs, what do they show you?
They typically log authentication attempts, including failures, and often capture the source IP address or hostname of the machine sending the bad credentials. That's your target.
And it's often not the user's main computer.
Very often, no. The source is frequently something overlooked. Could be a scheduled task running with old cached credentials. Could be a service account whose password wasn't updated everywhere. Or, increasingly common these days, it's a mobile device.
Ah, the phone or tablet still trying to sync email with an old password.
That's a classic. An old phone sitting on the bedside table trying to hit Exchange or a VPN every few minutes with the wrong password. These are tough because they're decentralized and the user might not even realize it's happening.
So once you track down that rogue device or task using the netlogon logs, what's the fix and prevention strategy?
Immediate fix is to disable or update the source. If it's a task, update the stored password or just delete the task if it's obsolete. If it's a mobile device, get the user to update the password or remove the account. Then, reset the user's password globally just to be safe.
In protection, how do we stop this from happening again?
Better credential hygiene is key. Regular audits of service accounts, for example. But more strategically, you leverage modern controls. Things like Azure AD conditional access can enforce stricter lockout policies, or even better, block legacy authentication protocols entirely. Those older protocols are much more likely to have issues with cached credentials.
Okay, let's shift gears now from identity reliability to, well, security incidents and recovery. The things we hope never happen, but absolutely have to plan for.
Yeah, this is where your planning hits the harsh reality of an attack. Having immediate practice response procedures is everything. Hashtag tag tag hey ransomware incident response, the containment phase.
Let's tackle the big one. Ransomware dot scenario. A file server gets hit. Files are encrypted. Maybe there's a ransom note. You do have backups, thankfully, but the attacker might still be active, moving laterally. What is the absolute first non-negotiable step?
Isolate immediately. Step one is always containment. You have to disconnect that infected host from the network instantly, pull the network cable, disable the NIC remotely, block its IP at the firewall, shut down SMB sessions to it, whatever it takes.
Why so drastic so fast?
2 reasons. Stop the bleeding, prevent the ransomware from spreading to other servers or shares, and second, prevent the attacker from maintaining access, potentially deleting logs or wiping evidence. While you're isolating, you also need to think about preserving forensic evidence, things like memory dumps, disk images if possible, relevant logs. That's crucial for understanding how they got in later.
Okay, contained. Now you need to figure out how bad the damage is, the blast radius, as they say. How do you do that quickly?
You look at access logs, file system auditing, maybe security logs on surrounding systems, who accessed what right before the encryption started, which shares were hit, then comes recovery. And the key here, the absolute key, is restoring from the last known clean, immutable backup.
Immutable backups. That term comes up constantly now. Why is simple backup not enough anymore?
Because modern attackers know backups are your escape route. They specifically target backup files and backup systems for deletion or encryption first. Immutability, or sometimes called vault lock, means the backup data itself is locked. It cannot be changed, deleted, or encrypted even by an administrator or the attacker for a defined period.
So it's tamper-proof for a set time.
Exactly. If your backups aren't immutable or truly air-gapped, they're just another target. After you restore, you must verify data integrity. Make sure the files are actually clean and usable, not corrupted or subtly booby-trapped.
Recovery isn't just getting the data back, though. You have to harden the environment right away, assuming the attacker might still be lurking.
Absolutely. Step 3 is immediate aggressive hardening. Reset all privileged account passwords in that segment or domain. Rotate service account credentials. Assume anything that touched the compromised system could be compromised itself. Patch the vulnerability they used to get in. Enforce least privilege. Make sure accounts only have the access they absolutely need.
And things like ABE, access-based enumeration.
Yes, deploy ABE. That means users only see the folders and files they have permission to access. It reduces the attack surface and stops users from browsing into places they shouldn't be. Deploy EDR endpoint detection and response if you haven't already. Use FSRM, File Super Resource Manager, to screen for and block known malicious file types from being written.
What about canary files? I've heard about those.
That's a smart tactic. Place decoy files or canary files, unimportant files in key locations. If monitoring sees those specific files get modified or encrypted, it triggers an immediate high-priority alert. It's like an early warning system for encryption activity. And, critically, enforce MFA, multi-factor authentication everywhere, especially for admin access, no exceptions.
And the final step, often skipped in the rush, the postmortem.
The postmortem is where you learn. You figure out exactly what happened, how they got in, why your defenses failed, and what needs to change. You run tabletop exercises based on this real incident. Those lessons must feed back into improving your security controls, your architecture, and your response plan. Otherwise, you're just waiting for it to happen again. #TADBD, handling service certificate expirations. LDAPS example.
Okay, let's move to something less dramatic than ransomware, but still capable of causing major outages. Certificate expirations. Specifically, let's say the LDAPS certificate on your domain controllers expires. Suddenly, applications that rely on secure LD key binding start failing.
The silent killer. This is almost always a failure of inventory and monitoring. The diagnosis is straightforward. Check the certificate store on the DCs. You can use PowerShell or certbuild dstore my to look at the certificates in the machine's personal store and check their expiry dates.
Found the expired cert. Now you need a new one from your internal enterprise CA. What are the common mistakes people make when requesting that replacement?
Two big ones. Forgetting the required extended key usages, or ECOs, and messing up the subject alternative names, the SANs. For LDAPS, the certificate needs the server authentication EKU. And the SANs absolutely must include the correct, fully qualified domain names, FQDNs, of the DCs, and possibly the domain name itself so clients trust it's a valid certificate for that service.
Got the new certificate. How do you deploy it safely across all DCs and make sure it's working?
You typically import it into the personal store on each DC. AD replication might handle distributing the certificate object, but the binding is local. Sometimes you might need to restart the Active Directory Domain Services, ADDS service, or even schedule reboots of the DCs one by one during maintenance windows to force them to pick up and bind the new certificate.
And verifying it's actually working.
You need to ensure the entire certificate chain, including any intermediate CAs, is trusted by the clients trying to connect. Then you watch the event logs on the DCs. Look for event ID 1220 or sometimes 36882. Those typically confirm that the DC has successfully bound the new certificate for LDAPS and is listening securely on TCP port 636.
So the real takeaway here is prevention through monitoring.
Absolutely. You cannot rely on calendar reminders. You need an automated system, whether it's a script, a monitoring tool, or features built into your PKI or cloud platform that inventories all your certificates and sends alerts weeks or months before expiration. Turn these emergencies into planned maintenance. #SMB, network security incidents, SMB traffic spike.
All right, let's look at a network-based security alert. You see a sudden, huge spike in SMB traffic originating from inside your network, maybe heading out. This could be data exfiltration or maybe an attacker moving laterally very quickly.
Yeah, a big unexplained SMB spike is definitely cause for alarm. You need to investigate fast. The first step is to get visibility into that traffic. That means starting packet captures on relevant network segments or, often better, using ETW tracing.
ETW event tracing for Windows. Why is that sometimes better than just grabbing packets with Wireshark?
ETW is a low-overhead, kernel-level tracing mechanism built into Windows. While packet capture gives you the raw network data, ETW can often correlate that network activity directly back to the specific process ID and application name on the host that's generating the traffic. This makes identifying the source, what application or service is actually causing this spike, much faster and more definitive. You need to know what is sending the data, not just which machine.
And if this spike is happening in a hybrid or cloud setup, say Azure or AWS,
The tools change, but the principle's the same. You'd immediately check your cloud network logs. In Azure, that's NSG flow logs. In AWS, it's VPC flow logs. These logs record all the network connection attempts in and out of your virtual networks. You're looking for unexpected connections, especially to external IP addresses or maybe cloud storage endpoints that don't make sense. That tells you if data is trying to leave your environment.
once you've identified the suspicious flow source destination, maybe the process and the mitigation seems focused on stopping it immediately.
Pure containment, yes. Isolate the suspicious host from the network. Block the specific outbound destination IP or port at the firewall if you've identified it. Rotate any credentials that might be associated with that host or application, assume they could be compromised. And longer term, apply stricter egress filtering controls. Use firewalls, maybe data loss prevention, DLP tools, combined with EDR analysis to understand why this traffic is happening and block malicious transfers definitively.
Okay, let's move from security containment now to focusing on keeping the core platform services highly available. Virtualization, clustering, essential network services.
Right, this is about the bedrock stuff, the hypervisors, the failover clusters, DHCP, DNS, the things that just need to work always. ###TaggyB, virtual machine, and patch management.
First up, a classic headache. You patch a critical VM, maybe a Generation 2 VM, and it do screens on reboot. The patch was meant to fix things, now it's caused an outage.
Yeah, the dreaded post-patch BSOD. First step is triage. You need to get that crash dump file, the memory.dmp. Then you need to analyze it, usually with WinDbg.
WinDB. The Windows debugger. What are you actually looking for in that dump file?
You're looking for the smoking gun, the faulting module. Was it a specific driver, a core kernel component? Is it related to a known issue with that specific KB update interacting with something else on the system, maybe third-party software or hardware? WinDbg helps pinpoint the cause of the crash. The immediate fix is often booting into safe mode and rolling back that problematic patch.
But rolling back is reactive. How do you prevent this from happening again? What's the strategic approach?
Prevention is multi-layered. 1. Always snapshot the VM before applying significant patches, especially kernel-level ones. 2. Rigorous pilot testing. Deploy patches in rings, starting with test dev, then maybe a small group of low-impact production servers before hitting critical systems. 3. Check the HCLs, the hardware compatibility lists, especially for your virtualization hosts. A patch might be fine on its own, but if it conflicts with outdated host firmware or storage drivers or network drivers, it can destabilize the guest VMs.
So checking host compatibility is key.
Absolutely, and ideally you use cluster-aware updating, CAU, if you're in a Hyper-V cluster environment. CAU can automate the patching process across nodes, and good implementations include pre-checks to validate things like driver compatibility before it starts rolling out the updates.
Okay, another VM issue.
Yeah.
Performance. A VM starts hogging CPU on the host, impacting other VMs. CPU saturation.
First, verify it is the VM causing host saturation. Use the hypervisor's performance counters and resource metering tools. Then look inside the guest OS. Is there a runaway process? A misconfigured application? Maybe antivirus scanning going crazy because exclusions weren't set correctly.
Once you find the cause.
If it's a runaway process inside the VM, you fix that. If the VM legitimately needs more CPU than the host can provide, you have options. You can try limiting its CPU usage via caps or reservations in the hypervisor settings to protect other VMs. Or, if the workload has simply outgrown its current resources, you might need to scale horizontally, migrate some services off that VM, or migrate the VM itself to a more powerful host. And definitely set up performance alerts that can trigger automation, like initiating a live migration if CPU usage stays high for too long. ###TagTab, clustering and high availability.
Moving on to clustering. It promises high availability, but things can still go wrong. Live migration latency spikes, users complain during VM moves. What usually causes that?
9 times out of 10, it's network contention. Live migration pushes a lot of data, the VM's memory state, across the network very quickly. If that migration traffic is sharing the same network path as your primary storage traffic, like ISCSI or SB storage,
They fight for bandwidth.
exactly, they choke each other out. The absolute best practice is to have dedicated separate network adapters and switches just for live migration traffic, ideally high-speed ones. Also, consider using network technologies like SMB Direct or RDMA if your hardware supports it, especially for the storage network, to reduce latency and CPU overhead.
Other mitigation tactics.
Schedule large migrations during off-peak hours if possible. Limit the number of concurrent live migrations happening at once. And if you're using storage spaces, Direct, S2D, check the health of your cache tier failing SSDs, or outdated firmware on storage controllers can absolutely bottleneck migration performance.
What about the nightmare scenario? A network partition happens and the cluster loses quorum. Everything just stops because the nodes can't agree who owns what.
Loss of quorum is catastrophic for a cluster. First, check your dynamic quorum settings. Is it enabled? Then, crucially, look at your witness. Where is it? Is the witness resource, like a file share or a disk, still accessible to the surviving nodes? Often in a partition, the witness ends up on the wrong side, making quorum impossible.
So witness placement is key.
Critical. You need a witness that's resilient to single network failures. Using an Azure Cloud Witness is a great option for geographic separation, or at least ensuring the file share witness is on a completely separate infrastructure stack. You might need to manually force quorum in an emergency, but the long-term fix is better witness placement and improving network resilience, redundant network paths, especially for the cluster heartbeat traffic.
One more cluster issue. Failing production checkpoints, or snapshots. Admins rely on them, but sometimes they just fail to complete.
Checkpoint failures, especially on busy VMs, often point to issues with VSS, the volume shadow copy service, inside the guest OS. VSS is responsible for quiescing the application, getting databases and applications into a consistent state before the hypervisor takes the snapshot. If the app isn't VSS aware, or if VSS is broken inside the VM, the checkpoint might fail, or worse, succeed but be inconsistent and unusable for recovery.
So, checkpoints aren't always reliable backups.
They're great for quick rollbacks, but for true DR, especially for databases or transactional apps that aren't perfectly VSS aware, you should rely on proper application-level backups, not just hypervisor checkpoints. Verify VSS integration is working, check event logs inside the guest for VSS errors, but don't make checkpoints your only recovery strategy for critical systems. #TAC-TAC-TAC-C. Critical network service failures, DHCP and DFS.
All right, let's touch on a couple of critical network services. First, DHCP scope exhaustion. The pool of available IP addresses runs out, and new clients can't get online. Huge impact.
Total business stopper. You need immediate action on two fronts. First, reclamation. Hunt down unauthorized devices, maybe printers or IoT things that grabbed an IP they shouldn't have. Aggressively reclaim stale leases IPs assigned to devices that haven't been seen in a while. And critically, shorten the lease duration, especially for transient clients like guest Wi-Fi or VDI sessions. A 3-day lease for a device that's online for 3 hours is just wasteful.
And if reclaiming IPs isn't enough, because you genuinely have that many devices,
Then you need expansion. Either resize the existing scope if your subnet allows, or better, set up DHCP failover or load balancing with a partner scope on another server. This provides redundancy and more available addresses. Strategically, deploy an IP address management (IPM) solution.
IPM helps track usage.
Exactly. IPM helps you monitor utilization trends across all your scopes, reserve ranges for specific purposes, track down rogue devices, and plan capacity proactively so you don't get surprised by exhaustion again. If it's a really large, flat network causing issues, you might need to look at network segmentation with VLANs too.
Okay, second service. DFS, Distributed File System. Users complain about slow access to a DFS namespace share, maybe from a remote office.
Slow DFS access is almost always about target referral. The client isn't getting pointed to the best, closest, or fastest server hosting the data. First, check your DFS namespace configuration, specifically the site costing settings in Active Directory sites and services. This tells DFS how far away different sites are.
And replication.
Yes, also validate DFSR replication health again. Is the data actually up to date on the local target server the client should be using? Verify that a local target server is configured, available, and healthy. Often, the client is unnecessarily getting referred to a server across a slow WAN link.
How do you optimize that referral in the data transfer?
Ensure site costing is accurate. Adjust the DFSN referral ordering to explicitly prefer local targets for clients within the same site. And for the data transfer itself, enable remote differential compression, RDC, on the file servers if possible. RDC minimizes WAN traffic by only sending the changed blocks of a file, not the whole thing again. Always measure latency and user experience before and after changes to confirm improvement. All right, moving into the cloud and hybrid world. Troubleshooting complexity definitely ramps up here. We're looking at identity challenges, cost governance, and cloud-native designs. #TAG-TAG-HASIDAY. Cloud identity and access management.
Cloud identity brings new tools, but also new friction. Azure AD conditional access, for example.
Yeah.
Super powerful for security, but it often breaks older legacy services that can't handle modern auth challenges like MFA.
Yeah, the classic clash between modern security and legacy systems. When CA breaks something, you first need to identify what is breaking. Usually it's a non-interactive sign-in, like a service account used by an old application or script that just can't do MFA or doesn't run on a compliant device.
So what's the immediate fix? And the long-term one?
Immediate fix is often to temporarily exclude that specific service account or application from the problematic CA policy, but that's a stopgap, a security exception you don't want long-term. The real solution is to modernize the application. Migrate it to use modern authentication protocols like OPA 2.0 or OpenID Connect, or maybe use certificate-based authentication. Get rid of the dependency on legacy protocols that CA is designed to protect against.
Okay, let's talk privileged access. PM and JIT, privileged access management, and just-in-time access. Essential concepts, but how do you implement them effectively in a hybrid world, both cloud and on-prem?
The tools differ, but the principle minimizing standing privileges is the same. In the cloud, specifically Azure, the tool is Azure AD Privileged Identity Management, or PM. You configure eligible assignments for high-privilege roles, requiring users to activate the role, often with approval and justification for a limited time. Access is temporary and audited.
And on-premises. PM doesn't directly manage on-prem AD groups.
Right. On-prem, you focus on a tiered administration model. Use dedicated, highly secured, privileged access workstations, pause, for admin tasks. For granular control, especially for things like PowerShell remoting, you implement JEA just enough administration. JDA creates constrained PowerShell endpoints that let admins run only specific commands or scripts without needing full local admin rights. You might also use third-party PAM solutions that can manage temporary group memberships in AD. The goal everywhere is to eliminate permanent, standing, high-privilege access. Hashtag B, cost, compliance, and governance.
Cloud costs, always a fun topic. You get that Azure bill, and egress charges have suddenly shot through the roof.
Yeah.
How do you track down that unexpected cost spike?
First stop is Azure Cost Management plus billing. You need to analyze the cost data, filtering by resource, service, location, resource group to pinpoint exactly what is generating that egress traffic. 9 times out of 10, it's data transfer leaving a region unnecessarily.
What causes that usually?
Often misconfigured service endpoints. Maybe VMs talking to a storage account over its public endpoint instead of a private endpoint within the VNet. Or cross-region traffic that wasn't planned. The fix involves architectural changes. Use private endpoints to keep traffic on the Azure backbone. Use Azure CDN or other caching mechanisms for frequently accessed data. Compress data before transfer. And use Azure policy to restrict resource deployment or data transfer across regions where possible. Crucially, set up cost anomaly alerts so you find out about spikes in hours, not when the bill arrives weeks later.
Governance across a sprawling estate. Lots of subscriptions in Azure or accounts in AWS. How do you enforce standards consistently?
You need hierarchy and policy. In Azure, use management groups to organize subscriptions, then apply Azure policy and initiatives at the management group scope. This lets you enforce things like tagging standards, allowed regions, required security settings, and even budget limits consistently across hundreds of subscriptions. Azure blueprints or deployment stacks can help define and deploy standardized baseline environments. Centralized logging and monitoring are also key, often funneling data into a central log analytics workspace or Sentinel instance, and use PM for managing access across that hierarchy.
What about compliance mandates like data residency or specific encryption requirements?
Again, policy is your enforcement mechanism. Use Azure Policy, or SCPs in AWS, to restrict resource creation to only approved, compliant regions, e.g. locking deployments to EU regions only. For encryption, use policies to mandate that services like storage accounts or Azure SQL Database must use customer-managed keys, CMK, stored in Azure Key Vault, giving you full control over the keys. And enforce the use of private endpoints and disable public network access for sensitive data services via policy as well. Make compliance the default, not an afterthought. #C AWS infrastructure design.
Let's switch focus to AWS for a bit. A common, secure design pattern. EC2 instances in a private subnet need to access S3 privately without going out to the internet. How's that done?
The standard best practice way is using a VPC gateway endpoint for S3. This creates a private route from your VPC directly to the S3 service within the AWS network backbone. Traffic doesn't traverse the internet or even a NAT gateway. It's faster, cheaper, and much more secure.
And you lock down access.
Yes. You then configure the S3 bucket policy to only allow access from that specific VPC gateway endpoint ID. And you use IAM roles attached to the EC2 instances to grant them permissions to S3, avoiding stored credentials. Least privilege all the way.
For larger organizations using AWS, setting up a multi-account landing zone is crucial. What are the core components for that kind of setup?
You start with AWS organizations to manage multiple accounts centrally. Then you use service control policies, SCPs, within organizations to set high-level guardrails preventing accounts from enabling disallowed services or creating resources in unapproved regions, for example. You establish dedicated accounts for specific functions, a central logging account, a security tooling account for GuardDuty Security Hub, etc., maybe a shared network services account. Access management is typically handled centrally via IAM Identity Center, formerly AWS SSO. And you use AWS config rules and possibly AWS Control Tower to enforce baseline configurations and compliance checks across all accounts from the start.
One more advanced AWS networking pattern, inspecting all outbound traffic from a VPC using third-party firewall appliances before it goes to the internet. How is that typically architected?
That usually involves the Gateway Load Balancer, or GWLB. You deploy your fleet of firewall virtual appliances from Palo Alto, Fortinet, etc. in a dedicated security VPC or within the existing VPC. You put a GWLB in front of them. Then, in your workload VPCs, you modify the route tables. Routes for outbound traffic 0.0.0.00 are pointed towards a GWLB endpoint deployed in those VPCs.
So traffic gets routed to the endpoint, then the GWLB sprays it across the firewalls.
Exactly. The GWLB distributes the traffic to the active firewall instances for inspection. After inspection, the traffic is routed back through the GWLB endpoint and then out to the internet via an internet gateway or NAT gateway. You have to carefully consider routing and high availability, including whether you want the system to fail open, allow traffic if firewalls fail, or fail closed, block traffic, depending on your security posture. It's a complex but powerful pattern for deep egress inspection.
Okay, our final section. This is about weaving all these reactive fixes into proactive strategies using resilience planning, automation, and continuous optimization. #NWA, backup and disaster recovery strategy.
Let's start with backups. Auditors, regulators, and just plain common sense are now demanding immutable backups. That air gap requirement isn't just nice to have anymore.
Because ransomware targets backups directly. So technically, how do we achieve that immutability?
You use the features built into modern backup platforms. Azure Backup has immutable vaults. AWS Backup has Vault Lock. Many third-party vendors offer similar write once, read many, worm, or immutability features. The key is configuring it so that backup data, once written, cannot be deleted or modified for a set retention period, even by privileged accounts.
Beyond the tech feature, what operational controls are needed?
You still need logically or physically air-gapped copies where possible, may be replicated to a different region or cloud, or even tape if necessary for long-term retention. Crucially, you need separation of duties. The team managing backups shouldn't have the permissions to delete the immutable storage or shorten the retention lock, and enforce MFA for any operation that could affect backup integrity or retention.
What about achieving really aggressive recovery goals? Say, RTO under an hour, RPO under 15 minutes. Backups alone often can't meet that.
You're right. For those Tier 0 or Tier 1 applications, you need more than just backups. For the RPO data loss, you're looking at database-level replication technologies, synchronous replication, always-on availability groups for SQL Server, similar tech for other databases. These get your data loss down to seconds or minutes.
And for the RTO, recovery time.
That requires automation. Pre-scripted failover runbooks using tools like Azure Automation, AWS Systems Manager, or custom scripts. These automate the complex sequence of steps. Failing over the database, repointing application servers, updating DNS records. You can't meet aggressive RTOs manually under pressure, and you must conduct regular, full-scale DR drills. Quarterly is common for critical systems to actually test and prove you can meet those RTORPO targets. A plan isn't real until it's tested.
DR drills inevitably uncover problems like missed dependencies. You fail over the app server, but forget it needs a specific service count that wasn't replicated, or a DNS entry. How do you refine the DR plan after those painful discoveries?
Documentation and dependency mapping are key. Build or update your application dependency map, maybe using a CMDB or discovery tools. Understand the exact startup sequence, database first, then middleware, then API layer, then front end, for example. Reorder your DR runbook steps accordingly. Insert health checks at each stage. Don't proceed to the next tier until the previous one is confirmed healthy and functional. And always validate with clear success criteria and have a tested rollback plan in case the failover goes wrong. #B, performance and maintenance optimization.
Let's talk maintenance windows, a common pain. The nightly backup window is taking too long and impacting production performance.
Yeah, traditional full backups can be really resource intensive. The optimization strategy is to move away from frequent fulls. Shift to an incremental forever approach where you take one full, then only incrementals. Use synthetic full backups, where the backup software constructs a full backup image from the incrementals on the storage side without hitting the production server again.
What about at the hypervisor or OS level?
Enable change block tracking, CBT, if your hypervisor supports it, like VMware or Hyper-V. CBT dramatically speeds up incremental backups because the hypervisor tells the backup software exactly which blocks have changed, avoiding a full disk scan. Split large backup jobs. Don't try to back up everything in one massive job. Use multiple streams or jobs running in parallel. And leverage snapshot-based backups combined with off-host backup proxies to move the data processing workload off the production host or VM entirely.
Another performance killer, slow user logins, especially after deploying new GPOs or maybe a security hardening baseline. User logs in, stares at applying settings for ages.
You need to pinpoint the delay. The best tool for this is the Windows Performance Analyzer, WPA. You collect a boot or logon trace, and WPA visualizes exactly where the time is going during the logon process. Is it a complex logon script, slow drive mappings trying to connect, a poorly written WMI filter in a GPO taking forever to evaluate, or maybe synchronous GPO processing forcing everything to finish before the desktop appears?
How do you optimize based on what WPA shows?
If it's a heavy logon script, convert it to run as a scheduled task after logon so it doesn't block the desktop. Simplify GPO WMI filters or item-level targeting if they're too complex. Consider enabling asynchronous GPO processing where it's safe. This allows the desktop to appear while some policies continue applying in the background, improving perceived performance.
What about maintaining a consistent server configuration baseline? Hardening servers, ensuring settings don't drift. How do you do that idempotently?
Idempotency is key here. You want a tool that only makes changes if the server is out of compliance. It doesn't just reapply settings every time. Desired state configuration, DSC, either PowerShell DSC or tools like Ansible, Chef, or Puppet, is designed for this. You define the desired state, and the configuration management tool periodically checks the server. If it finds drift, a setting has changed from the desired state, it automatically remediates it.
And safety features.
Any good solution must include verbose logging, so you know exactly what it checked and what it changed. And crucially, it needs a what-if or dry run mode, so you can test your configuration definition and see what changes it would make before letting it actually modify production systems. Hashtag, hear ye, automation, and server lifecycle management.
Automation is critical for scale. Let's say you need to migrate massive file shares, terabytes of data, but preserving the NTFS ACLs is absolutely mandatory for security and compliance. What's the goal?
The old reliable workhorse is still Robocopy, but you have to use the right switches. The key ones are mirror to mirror the source to the destination, including deleting files in the destination that are gone from the source, and copy.datso.
What does that stand for again?
Data, attributes, timestamps, security, that's the ACLs, owner information, and auditing information. The S for security is critical, says that, and you lose all your permissions. You typically run an initial robocopy to precede the data, then run it again multiple times to catch changes, delta syncs, and then one final sync right after you cut over users to the new location. And always verify ACLs post-migration using PowerShell scripts or tools to ensure they carried over correctly.
Security nightmare. Managing local administrator passwords across hundreds or thousands of servers. How do you automate rotating those securely?
The standard best practice solution for Windows is LAPS, the Local Administrator Password Solution from Microsoft. It's free, integrates with AD, and automatically randomizes the password for the built-in local admin account on each machine, stores it securely in AD, rotates it regularly, and allows authorized admins to retrieve it when needed. It eliminates the security risk of having the same local admin password everywhere.
What if LAPS isn't an option, maybe for non-Windows or non-domain joined systems?
Then you need a scripted solution that integrates with a secure credential vault like Azure Key Vault, AWS Secrets Manager, or a third-party PAM tool. The script would run periodically on each machine, generate a new complex password, store it securely in the vault associated with that machine, and update the local account. Retrieval requires audited access to the vault.
Server builds. To ensure consistency and security from day one, a golden image pipeline is recommended. What does that typically involve?
It involves using automation tools like Packer from HashiCorp or Azure Image Builder or EC2 Image Builder in AWS. You define your base OS and then script the installation of necessary agents, monitoring security, apply hardening configurations using DSC or scripts, install baseline software, and run compliance checks, all as part of the image build process.
And validation.
Critically, the pipeline should include automated testing and vulnerability scanning of the image before it's published for use. You version control your images carefully. When updates are needed, like patches, you update the build script, run the pipeline again, test, and publish a new version, rather than patching running instances individually over time. It ensures consistency and reduces configuration drift.
Last one. A big strategic goal for many orgs is retiring the ancient SMBv1 protocol. How do you do that safely without breaking critical legacy systems?
It requires careful inventory and phasing. First, you absolutely must identify what is still using SMBv1. Run network captures, enable SMBv1 auditing on your file servers, find those old printers, scanners, maybe custom apps, or old NAS devices. Check if firmware updates are available for those devices to support SMBv2 or v3.
And if they can't be updated?
For devices that absolutely cannot be updated, you need to isolate them. Put them on a separate, restricted VLAN or network segment that has very limited access, perhaps only to a specific legacy file server that still has SMBv1 enabled just for them. Block SMBv1 communication at the network edge and between internal segments. Only then, once you've identified or isolated the dependencies, can you start disabling SMBv1 server-side and client-side via group policy or registry settings across the rest of your infrastructure. It's a gradual, careful process to minimize disruption.
Wow, that was an incredibly dense run-through. We went from Kerbero's time sync issues all the way to cloud egress inspection with GWLBs and building golden image pipelines. A real whirlwind tour of advanced troubleshooting.
It really covers a lot of ground, doesn't it?
Right.
But I think the main strategic point, the thing to really take away is shifting your mindset, moving from just being reactive firefighters to proactively designing for resilience.
Right, every fix we talked about, implementing immutable backups, enforcing least privilege with PM or JEA, automating hardening with DSC, it's all an opportunity to build stronger, more robust systems.
And that structured approach we kept coming back to, diagnose, isolate, remediate, prevent, that applies everywhere. AD, virtualization, cloud, network. The process is the same, even if the tools change.
It's about learning from incidents to make sure the same incident doesn't happen again, whether that's fixing a bad GPO filter or finally migrating off a vulnerable legacy protocol.
Exactly. Don't just fix the symptom, fix the underlying cause and improve the design.
Okay, so here's our final thought for you, the listener, to mull over. We've seen how specific tools solve specific crises. LEPS for local admin passwords, Robocopy for file migrations, PIM for cloud privilege. Those are often the immediate tactical responses in the expert playbook. But thinking bigger picture, what single major architectural change could you make in your environment over the next, say, 12 months that would offer the biggest return? Maybe it's finally getting rid of NTLM and moving fully to Kerberos and modern auth. Maybe it's implementing true microsegmentation using NSGs or your firewall platform. What's that one big shift that would reduce complexity and dramatically improve your security posture? That's the strategic question to ask yourself now.